Saxon's Trig, lesson 107, is about the convergent geometric series. Now, several lessons ago, we did the geometric series, the sum of the geometric series, and I did not take the time to prove it to you. So they review it again here in this lesson. So I am going to just go over it a little bit more so that you can understand it, since I skipped it before. So if you take a series and it's going to have n numbers in it, however much that would be. We know that the first one is a sub 1. We know that the second one is that number multiplied with the common ratio one time for the exponent. And then the next term would be the same starting number multiplying with the r squared, and then the r cubed, and so on, until we get down to it multiplying with the n minus 1 as the last term. So this is the regular series just written out. Now, someone decided, a mathematician in the past, to what happens if we multiplied this equation by negative r. So that's what you're seeing here. So this multiplied with negative r is a negative r s to the n equals, and then this a1 gets multiplied with the negative r and becomes minus a sub 1 with the r. Now I'm ignoring this first piece, and I'm going to come back to it, and I'm lining these up, or attempting to get them close to lined up, so that this a sub 1r is matching up with this minus a sub 1r. But let's continue our pattern. When I then multiply this one with negative r, I get negative a sub 1 with the r, and the r making r squared. I'm just choosing to line it up with the one that matches it above. Same thing again. This minus with the a sub 1, and r squared times r is r cubed, and so on and so on and so on, until I get over to the last one, which is negative with the a sub 1, and then the r, when you multiply it with this, you end up with not the n minus 1, but just the n. So now when you add these two equations together, this s sub n minus the r s sub n equals, and this didn't have any match underneath it to cancel it, so it remains a sub 1. And then all of the rest of these, because this one is positive and this one is negative, they are crossing off until you get down to the very last one. Now the one that's written here would have had a term before it which crossed it off, leaving me with the very last one, the minus a sub 1 r to the nth power. Then I'm pulling out the s sub n, which is shared in both, and since I need a placeholder for that position, it's a 1, and I pulled the s sub n out, leaving the r. And then this is just the rewrite, and then rather than having it as plus and then the negative, I just wrote it with the minus to try to match the format. And now the last part is to isolate the s sub n by dividing by the parenthesis 1 minus r. And this, if you'll recall, is the formula provided for you for the sum of a geometric series. Okay, so in this lesson, they're taking that and they're now talking about what happens if it is a convergent geometric series. All right, so to talk about that terminology, I first need to say what we're going to do is we're going to take this part here. Oh, you know what? I didn't write the final part. S sub n equals, factor out a sub 1. That leaves you a placeholder of 1 minus the r sub n all over the 1 minus r. Okay, so now that it's in that, if I take this and I picture it as a very small number approaching 1, and when we talk about things approaching, we're talking about a calculus term that hopefully you will use next year, and that is limit. So when we approach something, we call it its limit. It can't go past its limit. So if I picture this as like 0.99999, that's basically a 1. So if I have the 1, then I'm doing 1 minus 1. No, hang on. I'm saying that backwards. this was really, really small. The r to the nth would be like 0.000001. 1 minus that would be the 0.99999, which is approaching 1. So this whole value is basically approaching 1 as I get really, really small numbers in here. So they're saying 1 times something basically eliminates it off. And so we would just keep that the sum would be a sub 1 and not that part over the 1 minus r. And that is working for the convergent geometric series. So in the dark bolded words, they clarify, we can use this provided formula to find the exact sum of an infinite geometric series if the absolute value of your r, whatever your ratio is, can't be negative, so that's why it's the absolute value of it. If that absolute value is less than a 1, we say that the series is a convergent geometric series. If, however, the absolute value of r is greater than or equal to 1, it's called a divergent series. And the sum of a divergent series can't be found, only the sum of a convergent one. All right, so now that you sort of understand the basics, so I developed the geometric series formula for the sum of those, and now we're tweaking it to say that this one was really, really small for the common ratio, and therefore it's down to this formula. Find the sum in example 1 of the infinite geometric series that is 5 plus 5 halves plus 5 fourths plus 5 eighths, and so on. It's continuing. That's why they called it an infinite geometric series. So if we attempt to plug into the formula, a sub 1 would be our 5, and we have 1 minus, and we need the common ratio. So if I don't know it, and it's the geometric, we're going to take the second one and divide it by the first one, implied over a fraction of 1, flip and multiply. So this becomes 1/5, the 5's cancel off. So the common ratio is 1/2. So we're gonna fill in our 1/2 here. So then 1 minus a half is a half. 5 over 1 divided by a half is flip and multiply, so 2 over 1. And so that gives us that the sum is 10. Now, example 2. A ball is dropped from a height of 12 feet and it rebounds 2/5 of the fall distance on each succeeding bounce. In part A, how far will the ball fall on the 10th fall? So we need to do our a sub 10th fall. So the amount on the 10th fall, a sub 1 is our 12, and multiplying with the common ratio, and 10 minus 1 gives us an exponent of 9. The common ratio was 2/5. Just a second, I'm reading the question to make sure that I haven't missed anything. Fall distance on each succeeding bounce. How far will the ball fall? Yes, on the 10th. So this is all we need for the 10th part. So 2 to the 9, actually on my calculator, I think I would do 2 divided by 5, then give it the exponent of 9, then multiply it by 12. Let me see if I can find that. 10th fall, oh yeah, that's gonna be really, really tiny. So it's coming out 0.0031, and I'm gonna round off, they go further, 315. That is the 10th fall. Now, part B. What will be the total distance the ball will travel? Okay, so here is how much it did on the 10th one, but now it's asking for the sum of everything up to this 10th one. So we're gonna follow our formula. A sub 1 was the 12 over top of 1 minus, and our common ratio was the 2/5. And that's going to be a common denominator of 5 over 5. So 12 over 1, implied as a fraction, is over top of 3/5, flipped and multiplied to 5/3. 3 goes in here and in here, so 4 times 5 is the 20. So it bounces 20, and I know it was feet because the original was in 12 feet. However, this is not the full answer to B, and you have to be careful on these bounce problems to take this into account. The formula here gives you the sum of all of them from their rebounds, not from the initial drop. So, just a second, did I say 20? Yes, I did. Yes, and the initial drop, all right, so our full amount is 20, our initial drop is 12. You have to stop and figure out the extra little bit that the ball fell that was not part of the rebound. So 20 minus the 12 tells you that there is an extra 8 feet in there, and that needs to be combined with the rebound amounts for a total of 28 feet for part B. Okay, example 3. A rabbit runs 2 miles in the first minute, 0.8 miles in the next minute, 0.32 in the next minute. So right now I've got a series happening here. 2, 0.8, 0.32, and 0.4 times this distance in the next minute. How far will the rabbit travel in all if he continues this pace indefinitely? So our common ratio is going to be, take the second one divided by the first, and I would do that on a calculator, but that will be 0.4, and then they're confirming by doing like 0.32 divided by 0.8 also gives you 0.4, same thing, didn't matter which one you did. So we are using our formula here, so our first number is 2 over top of 1 minus our common ratio, which we just found to be 0.4, and that's going to be 2 over 0.6, and on the calculator I might put that in decimal. They chose to convert it back over to fraction and call it 10/3. Your decimal was going to be 3 point something. Goodness. So it summarizes, even though this is silly, that the rabbit, if it runs indefinitely, which obviously that would be impossible because a rabbit can't continue to run, it's going to die at some point. But if it did run forever, it's actually only going to travel 10/3 and miles. 10/3 miles. Okay.